Hello, everyone. Welcome to our session. Thank you for being here, everyone. Tonight, we're going to explore one of the least explored areas of Azure and Azure AI subsequently. And we're going to see speech, speech to text, text to speech, and the real voice API or live voice API, which is very interesting to explore in a deployment where we will integrate this new API for live voice or near real-time voice. And the integration will be to attach our text into this voice API and integrate it into our avatar, which of course will be an Azure avatar, and we will make it look like the avatar is talking in real time. I have to say this was one of the hardest workshops that I was really um, it was really hard for me to make it happen. And you will understand while we will explore the code and the deployment how hard it is, especially when you see that actually we will have two backends to manage. So far, I haven't found another way to do it better. But as you know, especially people who know me, I'm very open to discussions and making applications and projects better. So if you have any idea after you see this approach by me on how to make it work, well, I don't know, easier or avoid having two endpoints to manage this complex configuration. I'm sorry. I will be very happy to hear it and, of course, work with you to make it happen. This project is not yet published in my blog, either in GitHub. So it's really the first time that it comes into public. It occurred from a real use case where someone wanted to make this work for a training session. It is still ongoing, but I do have the capability to present it, and of course the theme is really different. I took the main idea and went a step further to introduce the avatar, for example. You may see some Greek characters in the presentation of this project, but it's nothing. So the project actually is this. We were looking for an application to present slideshows, present pre-configured, of course, slides to students with speech. So we needed an engine to uh, get the slides from a storage account, for example, or from wherever, and start playing them sequentially while reading the text that is either into the presentation or separate text that we are narrating, as we usually do when we, present a slideshow. The case also wanted the students to be able to interrupt this automated training, this automated narrator, with questions, either by text or by using the microphone. So whenever a student wanted to ask a question, they could just hit a button or open their microphone, ask the question, get their answer, and then resume their presentation. The idea is very smart and takes away the pain of some educators to uh, have repeated and repeated sessions over very basic presentations, which in reality can happen through an AI system or an AI engine and with a little help of automation and some custom code and functions. So we will see the whole thing end to end. What we will not see is the deployment to Azure. Um, the reason is that I'm not ready to deploy it to Azure. We may try if we have some time at the end. I'm not sure. We may try together to pull it to Azure. It is nothing in reality to do it, but it takes some time. You need to add some variables. You need to make sure that all the containers are ready, and yeah, we may try it. But the most interesting part, we will be able to see it. We will see the actual presentation, how the narration goes, and of course the integration of the avatar engine and how this thing with the two backends happens. I'm sorry. So I'm Konstantinos Passadis from Azure Innovators Hub, owner of this meetup group and Global AI Athens. Welcome to today's session about Azure Live Voice API and avatar creation. Thank you everyone for being here. You can find a lot of information in our meetup group, Azure Innovators Hub. I will show you a little bit later how our little community goes. A global AI Athens community about AI, and of course my personal blog, cloudblogger.eu. All the projects that you want to explore made by me can be found in my GitHub account. I will show you right away in my screen where you can find some very interesting projects. And I was honored with the the space in Azure Awesome IZD, where you can publish your template and have it there for people to quickly deploy. So for GitHub, you can use this one. It's salis.github.io, if I remember correctly. This is the link. Yes, this is my main page. I actually like it a lot. That's why I'm showing to you. I like a lot this page. So you will find here a lot of projects, but of course you will find the links to go to my GitHub account. And from here, you will see also my blogger, my cloud blogger, where also you will find here solutions. They really go hand by hand. The solution that is posted here in cloudblogger.eu is the solution that also has a GitHub repo. And the same will happen with this one in a few days after this presentation. So we are really lucky to have it here, uh, regardless the complexity. Again, thank you everyone for being here. Let's switch to our developer workstation. So this is a live session, so forgive me if I'm stumbling a little bit, or my focus is somewhere else, and my speech is not so synced with what I want to do in reality. But this is why we have the avatar and the live speech API, and we're going to see what this thing is. So let's go and explore a little bit speech in Azure AI Foundry. Let's take it from a little step back. So in Azure, as we know, all AI services previously known as cognitive services have been now renamed and taken over by Azure AI Foundry. There are still two categories of AI services. We still have OpenAI, where let's go and see this separation in. We still have this Azure OpenAI category of services, which in reality it's a service, a resource that you can deploy in Azure that hosts only OpenAI models. So you have everything from OpenAI. It was the first AI uh, partnership between Microsoft and OpenAI, and this is the child that came out of this marriage. OpenAI resource in Azure, where you were able to just deploy this resource and get your own access to GPT models through Microsoft. So you didn't care about what OpenAI did, and if you were truly hardcore Microsoft fan and you wanted to work only with Microsoft resources and Azure, this is the way that you usually do it. Deploy an OpenAI resource and use it. I'm sorry. So if I open this in a new tab, you will see that it is actually constructed by a very simple structure. It's a very simple structure. So you have the keys and endpoint, access through an API and the relevant keys. Networking, you can lock down access only for private networks or private endpoints or specific networks, public access and all that stuff. Stored completions, this is something new. I haven't explored it yet, but resource upgrade. Ultimately, what Microsoft did is they took everything and they put it under the label of Azure AI Foundry. So, including OpenAI now, you will see that you will have some banners when you open Azure OpenAI that will say, "Hey, let's go and upgrade your OpenAI resource to Azure AI Foundry resource." So this is the how OpenAI looks like right now. Okay, but taking into account the fact that we are going to upgrade eventually and work with Azure AI Foundry, this is the way. We create an Azure AI Foundry resource. We select our region, and then we have this kind of resource, AI services. So, for example, I have this one. If I click on it, it will take me to the specific AI service that is of type Azure AI Foundry. You will see here what projects are deployed. You will see here that we have on the top an Azure AI Foundry resource, and then there is the hub, and then there is the project. This is how the tree is constructed. You can not do a lot through Azure Portal, and it makes sense. Azure Portal is to manage the infrastructure, so you can manage you can see your keys, and you can of course roll them, especially when you have exposed them or you have made a mistake or you feel that it's time to roll your keys. You can select, of course, networking or encryption. You can, of course, use your own managed keys, especially if you are dealing with sensitive information and you want your encryption to happen using your own keys. You can have a look in the costs, very basic stuff. See the security monitoring and, of course, monitoring in the infrastructure level again. Okay. But the real deal, as we say, is here. Go to Azure AI Foundry portal. So let's go to Azure OpenAI Foundry portal, where we will see our AI service named as such, Super User Voice. And here you can uh, explore the service itself or go also to the management center. Here is the management center for this specific Azure AI Foundry AI service. So you see here, we have the resource that has this super user voice. And what is this? If I click on it, it is a project. Okay, so it is a project. Let's go to overview. I haven't created any extra users other than the owner of the subscription. You can see connected resources. There are not any other connected resources here. And yeah, this is a very simple project. So again, you can go back to the project, and here is where you have your actual project. You can see how you can find your endpoints for AI Foundry and for different AI services. So you have the general Azure AI services endpoint, speech to text, and text to speech endpoints. If we want to play with the playground, you go to the playground, select your speech playground, and here is where it gets interesting. So now we are in the portal. The portal is a very easy way and user interface where you can explore what Microsoft has to offer regarding speech to text, real-time voice, and all that nice stuff. Translation, bus transcription, a lot of stuff. So what the playground is, it's exactly what it says. It's a way for you to try new things. For example, the voice live. This is what we are using, and this is what we're going to use through our code. Video translation, real-time transcription. This can happen in real time. Fast transcription, the previous transcription service. Batch transcription, when you can have files or URLs and start transcribing them. Speech translation, so as the speaker narrates, translation happens, or you can see here that you can upload the file and from the speech it can translate it directly to text and get it if you want later in speech. Custom speech, here is where you can start making your own cases, okay? Recording your speech, making your own voice, and all that nice stuff. It needs time for someone to get accustomed to this, and you need to be patient with yourself. So you can see here how pronunciation happens, how you need to speak, and all that very, very interesting stuff. I know that there are specialized companies out there that they are dealing only with this area of AI. So it's really, really interesting, but also quite complex. It may take time. If you decide to deal with this and you want to get involved, allow yourself time, be patient, and make all the mistakes you need to make in order to understand what's going on. This specific project, the the real the live voice API side by side with the trainer that I explained earlier, was something that was going on for almost 6 months. So you can imagine how much time I have invested into this one. Voice gallery pronunciation assessment, I'm sorry, where you can also you can see here that you have this nice view code button, which I wanted to show you. It's really very interesting that you can get the code ready. And of course, you have all the hyperlinks to go and get sample code. Makes your life so much easier. And with some help from Copilot or from GitHub Copilot, you can easily get something up and running and starting to understand how this works. Microsoft really makes our life much, much easier. So pronunciation assessment, you can see here.
Today was a beautiful day. We had a great time taking a long, long walk in the morning. The county slide was in full bloom, yet the air was crisp and cold. Towards end of the day, clouds came in, forecasting much needed rain.
So you can see here it has already done the assessment and it assesses how the speech is narrated given a specific text. And here you select the case, reading, speaking, or gaming, depending on the case, right? Of course, you can work with your languages, and if you want to have a custom endpoint, in our case, we don't. We can, of course, record our own voice. The voice gallery, here is where you will spend some time to get yourself familiar with the models that are available, especially for us in Greece. We don't have that much of a plurality here in models. In reality, the true Greek voices are very limited. Let me show you. That's why many people are turning into custom voice. It's really interesting to work with your voice and get rid of that. Um, we are used to some voices. We are listening them in the internet, in various videos all around, especially with this trend that's going on with AI. Our ears have listened to so many common voices coming from AI that we're getting tired of it. Imagine us in Greece where we have to work with this just these two voices. I thought it was one more, but yeah, this is the one. We have Athena and Nestoras, a female and a male. That's it. Of course, there are multilingual models, but the pronunciation is not good. It's not a real Greek pronunciation. They are multilingual, okay, I understand that, but you are listening the issue. It is not a Greek voice, as we say. Anyway, this is the voice gallery, and as I said earlier, you can work with your own voice, and this is where professional voice comes into play. Natural sounding synthetic voice. You can apply for limited access here. Personal voice, where you can work with your own voice, and of course, this message is very important. Due to the complexities of this type uh, of projects and technology, not every region supports everything. I guess you know that already, especially if you are um, working with Azure and you do have this hands-on. You have seen, I'm sure you have seen that uh, not all regions support all services. And the same applies for voice. The custom avatar. Again, you can create your custom avatar. Text to speech avatar. Here is what we're going to do. This is the avatar that we're going to use. You can do a lot of uh, play around here. You can make your avatar say what you want to say. Hello, my name is Lisa the avatar. And let's see, we can generate the video or play the audio directly.
Hello, my name is Lisa the Avatar.
Uh, Observe that if we don't add some pronunciation marks or commas, the the text to speech goes a straight line. Let's see what happens with a comma, if there is any difference.
Hello, my name is Lisa the Avatar.
Did you got this change in the voice? So what we just understood and learned, when we work with voice, it is very important to implement syntax highlights or annotations, or how can we say that? I said it earlier. Anyway, we need to apply commas and imagine that text is um, the reflection of the speech. So if you don't have a comma, the AI, the bot, will read it as a straight line. If you don't have a comma, if you don't have a dot, if you don't have an exclamation mark, you are not adding feeling to the voice. It's just a plain text, serialized and narrated. Okay, so we just added one comma and made this very simple phrase sound better and different. Now, if I click generate video, you will get our avatar in this sitting position. You can select also the position or how the avatar will behave in very basic things like if the avatar will be seated or not. And here it is.
Hello, my name is Lisa the Avatar.
Observe her lips.
Hello, my name is Lisa the Avatar.
Observe that the lips now are in sync with the text, okay? And of course, the comma, as I said earlier, is what makes the real difference in the way that the bot, the avatar, is speaking. Let's finalize here the audio content creation. Yeah, we have also audio here, and I'm not sure what this is about. I haven't explored this area, so I haven't a lot to tell you. Maybe in the next session we will be able to explore also audio. But now we're about everything is about speech and our avatar. So let's see this one. We can select a variety of avatars, and we can select also the position. We have casual sitting, graceful sitting, technical sitting, and all that nice stuff. Observe the different positions, different avatars, and let's go to view the code. Now, if we want to explore the code a little bit more, you will see that in the code is what allows us to set the features of the avatar. So we can select whether Lisa will be seated or if it will have a standing position and all that nice stuff. Okay. The good thing is that we can get the code, as I said earlier, directly from the portal, and it falls into our own um, responsibility to make it work. So let's see what we're making work. Let me show you. Let me open and start running our uh, interfaces. First one, the first interface is the backend. So let me go to the first backend. Is a backend trainer. So here we have this uh, node. I think it's correct. Yes. Now this is the backend. I will explain everything in a bit. Just allow me to run our backend so we can see what's going on. And the Python, I think it says, I don't remember this. Let me find it. Is it here? Is it the start avatar? No, I think it's, let me find the correct service. Azure Avatar, yes, it is the Azure Avatar. Yeah, I think it's this one. Correct. No, I don't want this. Delete this terminal. And it's not the Python, it is the Start Avatar API. You need a virtual environment to run this Python file, so it's very important to be ready and run it. Okay, the first backend is running. Let's see the second one, what's going on. No, it's running. Let me find it. And it is. Here it is. Let's do this one. It's the avatar that starts in a specific port. Let me find it. Now I need to run back quickly because I will spend my time here and I will not be able to find it. allow me to do this because there is a specific script that needs to be run, and I have a lot, and I'm also experimenting a lot. So yeah, we're building a lot of stuff here. Um, while I'm searching, I want to remind everyone that you can ping me on GitHub if you have a project that you would like someone to work with you. Just provide some help, some input, or whatever. You can ping me. Also, feel free to explore all the projects that are there. And if you feel that you can get one of them and make it better, or add make some additions, make some new features, or whatever you think you can make it work and look better, please ping me. I can work with you and work with your vision, let's say, to make things a little bit more interesting. Give me a moment here and we will find the correct script. A lot of scripts here. A lot of applications and projects. Come on. Yes, I think this is the one. Yes, finally, yeah, it was this command, and you don't need to open the virtual environment. You can run it directly as here. So we have the two backends running. The first backend is this one, localhost 3000 is the node backend. The secondary backend is this Python backend running in 8001. What you notice here is WebSockets. So this is a, a very important aspect of our integration for us to be able to fetch the avatar into our code and eventually present it through our front end. We need to work with WebSockets. It was something that the Node backend was not able to do it, at least as long as I tried to do it. I had to uh, find another way, and the other way was to work with Python. So the file is this one. It was correct, selected from the beginning. It's the Azure Avatar Py. This is the file. You can see here that it's also communicating with ICE servers. And if you have any experience with telephony or voice and proxying voice and all that stuff, you know that ICE is a type of proxy or a type of helper server outside of your perimeter network that helps facilitate the streaming part of an application that needs WebSocket in real time. This is the file we're going to return a little bit later. Let's go to the interesting part, the front end. Let's see. The front end, yeah, we are in the front end. So npm run dev. The selection, the language or the framework of my choice is usually React with Vite and TypeScript, a very common um, uh, combination of I'm sorry, of frameworks for front-end development. I also like a lot Next.js because you are getting rid of all this separation between front-end and backend, and now modern development. I think it will be this one. It will be not to deploy a separate bucket. It will be integrated into your code. So Next.js offers us this capability with the next router or or next pages. So you have everything into one uh, code base, and you don't need to manage separate backend. Anyway, so far, uh, React, Vite, and TypeScript as the frontend, and Node Express, I'm sorry, as a backend is fine. So let's see what's going on here. What we have here. Let's see the first part, the easy part. It is in Greek. So what the students here will do is get their URL, probably sign up. We can easily add sign in, sign up controls and user controls, my account and all of that stuff. And they start narration. So the AI will start telling or narrating the content, and we, I'm sorry, and we are waiting for the narration to start. Okay, so the student can pause, can restart, and all that nice stuff. Let me see if we have any funny errors. No. So this is the first part, okay? And it's narrating. I know you can hear nothing. I think I have removed this type of narration to honor the avatar. Now, the important stuff. The student can ask questions. So let's see what are the advantages of 5G. Let's see how this works. This is really interesting because it involves OpenAI. We should have been
5G
okay.
technology
Yeah.
offers several key advantages. 1. Higher speeds. 5G can provide download speeds up to 10 times faster than 4G, enabling quicker access to data, streaming of high definition content, and smoother online experiences. 2. Low latency. With reduced delay in data transmission, 5G improves real time applications like gaming, video conferencing, and autonomous vehicles. 3. Increased capacity. 5G supports more devices simultaneously, making it ideal for crowded areas like stadiums or urban centers, and for IoT Internet of Things applications. 4. Improved reliability.
Okay, I stopped it because it doesn't matter now to hear everything. I just wanted for you to understand, and now I know that you can hear it. That's why I stopped my camera to go in my secondary PC and be sure that you can hear the sound. So what happened here? Let's explore a little bit this one so we can understand how text-to-speech works in the context of on demand, let's say. This part is easy. I think we can narrate. Or I have removed it. I think I have removed this part. Doesn't narrate. Sorry. Yeah. So the student can interrupt this type of narration, make a question. They have some pre-selected questions, but they can use the microphone. This is a remote station, so I can't use the microphone in reality. But apart from the microphone, they can write the question in text and get an answer on demand. So I can ask whatever I want here. The point of this is that facilitate real-time interaction and provide the feeling that this thing happens in real time. And it is very easy to do it. Why? Because we are utilizing OpenAI. If you see now the backend code, let's go to our backend, you will understand here that we have a very nice Azure TTS that is doing the text to speech. So it's reading the original, uh, here it is, the OpenAI. It's reading the original question from the user, okay, sends the payload to the OpenAI model, and that's why we have here different variables. The environment contains a plurality variety of environment variables. So we have OpenAI endpoint just for this case. The OpenAI endpoint generates the text response. It goes through the speech endpoint, and this is how we have pure text to speech. The payload is coming from OpenAI in the form of text. Text is taken from our speech endpoint and presented via audio to our frontend, just like you saw it uh, one moment earlier. Let me find also the server. Here is the server, and we have the real-time voice, the voice live endpoint. No, I want the speech one. This is the OpenAI speech route. This is the WebSocket. Yes, this is the text-to-speech that is using Azure TTS. Here it is. And here it is. Okay. And we get our text-to-speech. And now where is the avatar coming in into the picture? In order not to break this nice thing, what we've done is that we embedded the responses coming from our OpenAI into the avatar. You have the capability to say, okay, I want voice only, voice live API, or the full avatar. So let's go with the full avatar. And let's ask here something about telecommunications. So um, what we can ask, I don't want to select something from the already questions. Can you explain the telegraph in simpler terms? Okay, what are the rotary telephones? You know the rotary telephones? If you are old enough, you may know them. Let's see what will happen here. So let's have a good look and send it. It will take some time to generate the call to the speech endpoint, to the avatar, and integrate our two backends so the avatar will look like it says what we are hearing. The lips are saying what we're hearing. Let's give it a refresh to wake up. Full avatar. I don't know if it keeps history. No. What are the rotary telephones? Okay, it's trying to load. Let's see. It will speak.
Rotary telephones are a type of phone that were widely used before the app. They have a circular dial with numbered holes, 0 to 9, and a finger stopper. To make a call, you insert your finger into the hole corresponding to each digit of the phone number and rotate the dial clockwise until it hits the stopper. The dial then returns to its original position, generating electrical pulses that correspond to the dialed number. These pulses are sent down the phone line to the telephone exchange, which connects your call based on the number dialed. Rotary phones were popular from the 1920s to the 1980s before touch-tone phones became more prevalent. Although now considered vintage, some rotary phones are still functional and appreciated for their nostalgic charm. They don't
Yeah, very nice. I think that we saw how the lips really adopt what the text is saying. Now the text was too much, and there are um, uh, functions in place to make sure that we are not taking over everything regarding bandwidth and the API. But yes, that's it. Let's see another. Let's take one of the questions that are already there and send it. You can see here what's happening in the background. This is the Python backend.
Voice over Internet Protocol, VoIP, allows you to make phone calls using the internet instead. Here's how it works. 1. Conversion. Your voice is converted into digital data packets. This is done using a device like a computer, smartphone, or a specialized VoIP phone. 2. Transmission. These data packets are sent over the internet to the recipient. VoIP uses protocols like SIP, Session Initiation Protocol, to establish and manage the call. 3. Reception. On the recipient side, the digital packets are received and converted back into sound. This allows the person to hear your voice. 4. Internet connection. VoIP requires a stable internet connection. It can work over wired connections, Wi-Fi, or mobile data networks. VoIP is efficient and cost-effective.
Very interesting, right? Yes, there is a stop here, a hard stop, and this is done on purpose. But yes, this is how it works. Let's return now to see how this is implemented. So, first of all, we have to look into this one. This is the start of everything. Azure text to speech. Let's see what's going on here. So you can see we need, of course, the Cognitive Services Speech SDK because we are using the SDK. We're not using direct API calls. The SDK is the software developer kit, as you know, and we can utilize as making API calls, but this is happening within the libraries of the SDK. So we are setting a function that we name it the Azure DTS, and this is what it's calling the Azure Speech Key and the Azure Speech Region. Be careful when you implement speech. You need a separate speech service here. If I remember correctly, you will see that I have this separate service deployed as speech service. Give a moment to show you. Speech. Yes, you can see here that I have a dedicated speech service. Of course, I'm using the F0 pricing tier, which is the free one. And especially if you want to go to production, you will move away from the F0 because it has its limits. So, dedicated speech, highlight. There is a config for this speech, but it is not honored because we are using the avatar's voice. Okay, we are passing an null for audio config to get the result as in memory. This is the fastest thing that we can do about the text to speech. And then we create this synthesizer. Everything is taken from Microsoft and the code that they provide for us in order to make our application work. This is very simple. This is very, very simple. Now, let's go to our avatar. The avatar pipes. Here it is. So here is the things where it got very, very complicated. You can see already that we are using a long file here. Of course, we are getting the speech configuration from our environment variables in order to apply this text to speech into our avatar. We create this Azure Avatar service. You can understand that we are using WebRTC sessions where we can store them, and we are using the ICE server information from Azure Speech Service. This is this is not something that I made out of my mind. If we go to Microsoft documentation and start digging here, uh, you will see that things will start to get a little bit complicated, especially when you want to see how can I utilize this one with an avatar. How can I use this live voice API with an avatar? So you have this first quick starts. Voice live with Foundry models, voice live with Foundry agents. This is nice. And bring your own model. Let's see the models because we're not using agents, we're using avatar. And let's try to find scenarios. I think there is somewhere hidden here the avatar. Okay, this is create a voice live real-time voice agent. This is about agents. I selected the models. I don't know why it went to the agents. And it provides instruction. You can see here we don't have a lot of options, Python or C Sharp. That's it for voice live SDK, right? For the voice live SDK. Here it provides the code. Very nice. But the issue is that I want to use this with the avatar. Okay, let's try to find voice live with an avatar. We will fall into the same link, as you understand. Oh, here is the reference. Yeah, I think this is the one. And this is where you start to get these new things. WebRTC based avatar streaming with video animation and blend shapes. This is exactly what we did. Our session was a WebRTC session. That's why we needed Python to work our WS protocol as you saw earlier. Again, I didn't make this out of my mind. I tried to integrate everything from the documentation. So this is the reference. Um, let's see if we can find text to speech. No, text to speech avatar. Here it is. Okay, yes. Real-time synthesis. And of course, we have SSML, which I haven't explored. The avatar capabilities, custom text-to-speech avatar are separate features. So voice tuning and custom text are separate features. Okay, we can use them independently, blah, blah, blah. And the avatar supported regions, this is also important. There are sample codes for batch synthesis, for real-time synthesis, and live chat with Azure OpenAI in behind. The second is what we try to, where we did and we try to do. And here is a sample code. And there is a chat sample. Somewhere along these lines, you will understand and you will find, you will see that here it is. This is exactly what I was looking for. Real-time avatar uses the WebRTC protocol to stream video. We need to set up the connection with the avatar service using a WebRTC peer connection. We need to create this WebRTC peer connection object. WebRTC is peer-to-peer and relies on an ICE server for network relay. Okay, so what's going on here? We have our endpoint and we have the peer that is the API of Microsoft. When we want to consume in our endpoint the avatar and apply parameters and configuration elements, the ICE server is a relay helper that help us get the information and make the video real. It is used also in other types of streaming uh, as well. So I'm not going to stay a lot here. Here's the documentation. Drop me a message if you want me to share this information with you. Uh, and if you are a little bit more patient, this project that we just explored, this one, it's going to be uploaded. I'm sorry, it's going to be uploaded in the cloudblogger.eu for a generic overview of how it is done. But also, all the code elements will be hosted in my GitHub repo. So, if you are again a little bit patient, the next days or 2 weeks, something like that, I will be able to create the post and also share the code in the GitHub repo. So, a little bit of a summary here. We want to sum it up. To get accustomed and get to know a little bit better how Azure speech to text and text to speech work, we need to experiment with it. Luckily, Azure AI Foundry has changed the field around how to do it, and we have ready code snippets where we can adopt, integrate, and make it work. The curve, the learning curve, as we say, it is much more easier uh, to work with. It's not that steep. Why? Because we have everything in our hands. So you need to dedicate yourself. You cannot do it with half a mind here and half a mind there. You need to be focused and you will make it work. You will be amazed by watching yourself doing something that complex. It's another thing to create web application, but it's another thing to create real-time voice and text-to-speech, and we all know that. Especially uh, we that we are trying to develop things into our workstations, the development PCs, which we have this feeling that it will not work, and seeing it work is really a very nice and well perceived feeling. So yeah, I like it a lot. Once you conquer or how can I say make a small application work with text to speech or speech to text or both, try to explore Python, WebSockets, and this specific article and documentation about the avatar. Alongside with the code that I will provide, you will be able to get your applications up and running in a very small window of time, especially if you are looking for something immediately around this area. Okay. Of course, we explored just a very small percent, just a 5% or 10% of the real capabilities. But we did it in a 360 view. Okay, we did the front end, the back end, and the secondary backend to facilitate WebRTC for our avatar. There are more to come, and I will try to create a second or a part two of this with advanced features and more and better user experience, meaning that the user will be able to make some selections or uh, configuration uh, configurations for their own experience. Maybe some users want a male avatar. Some users may want a female avatar. We will see how we can make this work for our users. We will also see how we can implement professional voice and personal voice. Get away from these canned voices. Okay, we're a little bit tired of hearing the same sounds again and again. And it's already 2 years into this trend. We need to start creating our own. So we will also do something around this. I think we are on time. I would like to thank you so much for being here with me. This video will be streamed and is streaming already in YouTube, and it will stay there for the rest of this channel. So remember to just subscribe to our channel. It is K Pasadis or Azure Vlogger. I want to thank everyone again. Forgive me if I made some mistakes or if there is something that you didn't understand. Don't hesitate to drop me a message or you know leave a comment, ping me on LinkedIn, ping me on my presence. I'm everywhere. I'm easy to find. So again, thank you so much. Have a beautiful evening, a beautiful morning, or a good night. Thank you, everyone. Bye bye.